Welcome back to the third tutorial about vidi suite. This tutorial is about the vidi red tool in its supervised mode. We will show how to edit regions of defects and discuss how the results can be exported at the end. This tutorial is done with images from a texture which we have already imported into the tutorial 3 texture workspace that we see here, and we can now, as usual, click on the white scissors in order to process those images and import them into the database. The images show a very irregular texture, and the defects that we are looking for are actually these blurred areas which have a reduced texture. Clicking on the histogram icon reveals the database overview, and we see that in total we have 575 images. Now luckily those images have already been labeled in a way that their file name contains the label bad if the image contains a defect. So we can go to the Actions menu and use the Label from File Name function in order to label those images automatically. That way, the system labels 79 images as defective, and we can go ahead and open the tool parameters in order to change some settings to improve the learning. For instance, since those textures could easily be flipped horizontally or vertically, we can use the perturbation setting both in order to augment our training data. Also, since the images from one to the next change quite a bit in luminance, we can add some variance to the luminance setting, like 10%, in order to get more training data out of the little that we have. Now this is done, we can move ahead and hit the train button in order to start the training. The resulting distribution of good and bad samples shows that there's a huge overlap between them, and when we actually look at the ROC curve, we see that we are very close to the diagonal, the area under the curve is very close to 0.5, and this classifier is actually very close to chance level. When we move the thresholds to the intersection of the two curves, we can see that if the system responds to something, it is actually not at all to the actual defect, but it responds to the regions in the images which shows the highest degrees of anomaly. And if we sort, for instance, for the not labeled images, this becomes even more clear. So in order to show the system what we are actually looking for, we need to switch to the supervised mode, and also we need to tell the system explicitly on some sample images what the actual defects are. So we select the labeled images, and now we enter through the context menu into the Edit Regions mode, and now we can go and draw explicitly, showing the system what the actual defect is. Hitting Enter, we move to the next image, and also here we show the system where and what shape the defect has. Now, since those defects appear in different locations, on different background patterns, different orientations, we do have to show the system several of those, such that the system can learn what is the actual important aspect of the defect and what aspects, for instance in this case, like the position, are irrelevant. Now that we have done this for a couple of the defects, we can exit the region editor by clicking the X in the upper right corner, and we can launch the training. The resulting distribution looks already a lot better. We see that the green and the red curve are very nicely separated. Looking at the receiver operating characteristics gives us an AUC of 0.99, so very close to 1, which would be the ideal classifier. Since we are still looking only at the labeled images here, they are sorted by ascending order, and therefore these images will show the ones which have the least strong response even though they have a defect. So we can go ahead and edit and add some more of those. In order to further improve the ability of the system to find those. All right. Now we can retrain. And after the second round of training, our area under the curve is equals to 1, and we have a perfect separation of the green and the red samples, and therefore a perfect classifier. Looking at the responses, we see that now the system is reacting to the areas in the images, even though they have not been trained. Moving higher up, we get to the samples which respond stronger and stronger, and also here we see very nice responses to the type of defects that actually we have been looking for. Now that we have those results, we often want to share them with other people. We can do this by going into the Actions menu and selecting Export Database. This opens a new browser tab which shows the results in one single page. We have here an area where we can choose different options. So for instance, instead of showing 2 views per line, we set this to 5. We can hide the file names, and we can choose to show the graphs. And once all those parameters have been set to our liking, we can close this small settings dialog and we can select Save Page As, and this will save the page under the name Tutorial 3 Texture onto the desktop. With these 2 files now, we can send them or share them, and anybody else can open that file again and look at the results without the need for having a vidi suite running on their system.